This is for Year 11 methods. We're going to look at question 7 from exercise 2H. We've got a situation where we have a pair of simultaneous equations. It's got a parameter, and we're trying to find the values for m, for which it gives me infinitely many solutions or no solutions. So for infinitely many solutions, we want the same gradient and y-intercept. For no solutions, we want the same m but different y-intercept. Now, in order for us to read off what the y-intercept and gradient is, we need to first rearrange the equations. So let's rearrange the first equation. 3x plus my equals 5. I want to make y subject, so I can move the 3x to the other side and divide both sides by m. Similarly, for the second equation, I can move the m plus 2 times x over the other side, so I get 5y equals m minus m plus 2x, and divide both sides by 5. And I can obviously see what my gradients and y-intercepts are. Now, first things first, for infinitely many solutions, I want my gradients to be the same. So m same means that I want -3 on m to be equal to -m plus 2 over 5. Now let's cross multiply, so we get -15 equals -m plus 2, mn plus 2. Since we have negatives on both sides, I can change both to a plus and expand the bracket, so we've got m squared plus 2m. I move all the terms to one side, so I'll move the 15 to the other side. M squared plus 2m minus 15 equals 0. And we notice we got a cross product. So our two numbers times together giving us -15, and add to give you 2. So the only option I can think of is -5, +5 and 3, -3. So m plus 5, m minus 3 equals 0. So by the null factor law, m equals either -5 or +3. Now we want the y-intercept to be the same as well. So we want 5 on m for the first equation as the y-intercept, and we want that equal to the y-intercept of the second equation, so m on 5. Again, we cross multiply, we've got 25 equals m squared. Take the square root of both sides. Remember, when we take the square root of both sides, we want the positive and negative root. So m would equal plus or minus 5. Now, looking at the equation, we've got a small dilemma, because we know that in order for the gradient to be the same, it either has to be a value of -5 or 3. And for the y-intercept to be the same, it has to be either +5 or -5. So the only value in which they both agree happens to be when m equals -5. So in order for the simultaneous equations to have infinitely many solutions, m has to equal -5. Because if you choose m equals 3, it means that they don't share the same y-intercept. Similarly, if m equals +5, it can't share the same gradient. So m equals -5 is the common value, which they happily agree with. So for part B, we want no solution, so we want the same m value. So again, for the same m value, you can either have m equals -5 or 3, but different y-intercepts. So they have the same y-intercepts at m equals -5, so we don't want that. We don't want that to occur. So the only solution is if m equals 3 for no solution. Hope that helps.